So, let us continue with problems number 11. 11 to 17 na lang 'to. So, after 3 problems, I will just pause and then continue with the next one or the final part. So, this is the problem for number 11. Liquid to liquid counterflow heat exchanger is used to heat a cold fluid from 120 degrees Fahrenheit to 310 degrees Fahrenheit, assuming that the hot liquid enters at 500 degrees Fahrenheit and leaves at 400 degrees Fahrenheit. Calculate the log mean temperature difference for the heat exchanger. Now, pupunta tayo sa heat exchanger. Uh, we have different types of solutions pagdating dyan, okay? Meron tayong tinatawag na arithmetic mean temperature difference and then logarithmic mean temperature difference. Simply, ang pinagkaiba ng dalawa, that the arithmetic mean temperature difference, it means that the temperature difference is, ang layo niya is arithmetically related to the other. Ibig sabihin, yung increments and decrements niya is somewhat meron silang common difference. Okay? Arithmetically. But when you're talking about logarithmic mean temperature difference for the heat exchanger, okay? Ngayon, the temperature difference between the two is somewhat exponential. Okay? Hindi sila, wala silang common difference, but they have a common ratio. Okay, going back to your algebra, di ba? Kapag logarithms, it deals with exponential growth. Okay? Or exponential decrements and increments. Pagdating naman ng arithmetic mean, ibig sabihin, the average temperature difference between the two flowing fluids. Okay? Now, saan po ba natin ginagamit yung LMTD? Okay? LMTD and then AMTD. Simply, sir. Okay? Kapag meron tayong heat exchangers and then ginagamit yan to know yung temperature difference between two hot bodies. Okay? So, meron kang formula dyan na conduction, convection, and then for the general formula, okay, the general formula for heat transfer is simply Q is equal to U area delta T. Di ba? Ito yon. Where U is the conductance. Makikita nyo dyan. Bibigay ko sa inyo yung formula. Q is the conductance. Okay? Let me check my notes. Ayun. Heat transfer in terms of overall conductance U, where U is the overall conductance. Conductance. Yan. Where the temperature difference can be specified as AMTD, arithmetic mean temperature difference, or simply LMTD. Or the logarithmic mean temperature difference. Ayan. Chinek ko yung aking paper. But yung overall conductance can be the total coefficient of heat transfer. Depende yan kung composite wall, fluid to fluid, pipes, tawag dito, the heat transfer on pipes, the heat transfer from fluid to pipes, okay? And so on, yun lang yun. Sinimplify lang natin yung U. Okay, that is the overall conductance. Okay. Ito na yung pinaka-general formula for heat transfer in terms of the overall conductance. Ito, maraming formula ito. Binibigay ko naman yun sa notes eh. Now, let's go back to the heat exchangers. Now, for heat exchangers, ano ba yung mga uri ng heat exchangers? Now, sir, magbigay ako ng example dyan. A condenser, that is a heat exchanger, kung saan meron kang cold water that absorbs the heat that is coming out from your fluid, commonly which is steam, okay? A hot fluid or oil. Pwede rin naman po na ang iyong medium of cooling is air, if that is air cooled, Or simply, pwede rin yun sa radiator, okay? Radiator, ang ginagamit na pang-coolant mo doon from the hot water coming out from your engine is air. Now, dalawang uri tayo ng heat exchanger. Number one, a parallel flow where the cooling medium is the same with the flow of the hot fluid. Now, for counterflow, ibig sabihin, yung hot fluid mo flowing through the heat exchanger tubes is in contact with a crossing flow na cooling fluid. Yan. So, ano po ba yung magandang diagram para maipakita natin siya? Okay, let's go with this. Okay? Let's go with this. Now, going with this, you have the concurrent or the parallel flow and then the countercurrent flow. Now, if the hot fluid, syempre, mas mainit kaysa sa iyong coolant, okay? Or the cold fluid. So, the temperature difference here and then the temperature difference here is at maximum. Okay? The temperature difference from your T hot, okay, T low, 1 and 2, okay, sa point 1 and 2, and then the T hot here, out and then out, okay? THO out, THO low. Yan. T hot pareho ito, T hot, T low. Ngayon, the temperature difference from here to here, sa dulo-dulo, is simply the delta T minimum. Okay. Now, when you're talking about AMTD, simply AMTD, arithmetic mean. Therefore, that is the delta T max minus delta T minimum divided by, hindi, arithmetic pala to, o di plus divided by 2. Now, that is the formula for your AMTD. Okay? That is the formula. Now, how about the logarithmic mean temperature difference? Now, for your logarithmic mean temperature difference, simply that LMTD is equal to yung delta T maximum minus delta T minimum divided by, logarithmic nga eh, o di na natural logarithm of the delta T maximum divided by delta T minimum. Okay? Are there cases, sir, na magzi-zero sila? Yes, there is. But I will show you the way para hindi kayo nalilito riyan. Okay? Now, tignan mo. Look at this. Okay? Either concurrent, countercurrent, mas maganda, nag-graphing ka riyan ng iyong temperature difference for you to map out kung ano yung magiging maximum temperatures and then minimum temperatures of the flow. Okay? And then, dun mo din malalaman and you can compare either what is the maximum and the minimum temperature changes. Okay. So much for that. Mas maganda sinusolve natin yung problem. So let's go with the problem again. Okay? Meron tayong counterflow heat exchanger. Okay? And then, heat used to heat a cold fluid. So ginagamit daw yung heat to cool, ginagamit yung heat to make the fluid hot from 120 to 310 degrees. So this is the cold fluid. Okay? That's the temperature. Assuming that the hot fluid enters at 500 degrees Fahrenheit and leaves 400 degrees Fahrenheit. Counterflow, so better way that we map it out. Ayan. So, maglagay tayo ng diagram. Mas maganda, nagdo-drawing tayo ng diagram. So, gusto ko violet. Ayan. So, this is your temperature. This is the length of your flow. And ang ibig sabihin, meron tayong cross flow. Okay, 120 degrees Fahrenheit. Okay, yun ang mauuna. So, from cold to hot. Mas gusto ko yung cold, that is in blue. Okay, to hot. 120 to 310. From here, 120 degrees Fahrenheit to 310 degrees Fahrenheit. Ayan. Now, meron tayong hot fluid from 500 degrees Fahrenheit to 400 degrees Fahrenheit. Slightly lower. Pero ito 310 to, di ba? Ito 310. Ito 200 something. Okay. Gusto ko yung hot natin is red. Okay? From 500 degrees Fahrenheit to 400 degrees Fahrenheit. So, redirecting the flow. So, the flow nung blue is papunta rito, pabalik. Okay? And then, tignan mo muna yung flow nung red, papunta rito. Now, hindi natin alam where is the maximum and where is the minimum. If this is 500 degrees, this is 400 degrees. Okay? Ang hinahanap dyan is the LMTD. Okay? Now, calculate the log mean temperature difference. Okay. Hanapin muna natin si Tmax and then Tmin. Tignan mo naman dito. So, 500. Ito, map natin itong dalawa. Ayan. Ayan. Tapos ito. If this is 120, this is 500, 310. So, delta T. Tignan muna natin to. If this is maximum or minimum. 500 minus 310, I think that is 190. Delta T, 1 muna natin. Okay. That is 190 degrees Fahrenheit. Yung isa, delta T, 2. That is 400 minus 120. That is, I think, 400 minus 20. Tama ba ang aking given? 500 minus 310. Pero pwede na yan. That is 420 to 20. Okay, pwede natin map out. The logarithmic mean temperature difference, LMTD, is equal to delta T max. Nasaan yung maximum mo? Ayun, no, nandito. Minus delta T minimum. Divided by ln, the natural logarithm of delta T maximum divided by delta T minimum. Yan. So, let us solve for LMTD. LMTD equal to delta T max. O, di 500. Doon ka magsimula. Pwede na yun. 500 minus 310 minus 400 minus 120. 120 ba yun? Oh, 120 nga. 120 divided by ln, ln, natural logarithm of delta T max, that is 500 minus 310 divided by 400 minus 120. Now, let us go with the LMTD. LMTD will be equal to, calculate. Yan. So, 500 minus 310, okay, minus 400 plus, kasi naging minus 120. Ayan. And then, the ln, natural logarithm of 500 minus 310 divided by 400 minus 120. You now have the value for your LMTD. LMTD will be 232 point, ayusin natin yung sulat. 232.099 approximately equal to 232.1 degrees Fahrenheit. That is now for the LMTD. Mas mabuti yan kung i-dino-drawing mo para nati-trace out mo yung maximum temperature. Okay? Okay. So, that is for the LMTD. How about the AMTD? AMTD. Ganun lang. AMTD, pakita natin. AMTD. So, delta T mean, delta T max, that is 500 minus 310 plus delta T minimum 400 minus 120 divided by 2. So, 190, 500 minus 310 plus 400 minus 120 divided by 2. That is 235. 235 degrees Fahrenheit. Okay, ganun lang kadali siya. How about problem number 12? A heat exchanger has an overall coefficient. Okay, overall coefficient na yan. So, that is U. 900 watt per meter squared degree Kelvin. U, overall coefficient of heat transfer. That is U. Or nu. Yung iba, mu. Okay? Yung iba naman ginagamit nu. U. The mean temperature difference is 20 degrees Celsius. So, that is delta T. 20 degrees Celsius. And the heat loss is 15,000 watts. Calculate the heat transfer in square inches. O, lista mo yung kanyang formula. Q is equal to U or mu delta or area delta T. Okay? So, hinahanap natin si area. Okay, mas gusto ko kulay blue naman ngayon. So, algebra, okay, Q divided by U delta T. Now, in inches, sabi inches squared. So, let us solve. Conversion lang tayo magkakatalo. Ano yung Q mo dyan? The Q is 15,000 watts divided by U, 900 watt per meter squared, 900 watt per meter squared degree Kelvin, multiply to the temperature difference, which is 20 Celsius degree. Okay, cancel na yon. Cancel natin yung mga same units. Okay. Ang matitira is meter squared. Now, wala naman tayong direct dyan, pero mas gusto ko kasing gamitin ito. Okay? Ano ba natandaan nyo pag meters? Meter squared. So, feet na lang tayo. Okay, daanin natin sa feet. So, meron tayong 3.28 feet per 1 meter. You multiply yung feet to inches para maging inches dapat nasa baba. So, meron tayong 12 inches per 1 foot. And then, don't forget to have this squared. Okay. Now, you will have the value for the area in inches squared. 15,000 watts, 900 times 20 times 1, 3.28 times 12, square natin lahat. Okay. The value will be 1291.008 inches squared. The area will be 1,291.008 inches squared. Now, that is the value for the area. Okay? For number 12. How about number 13? The mass flow rate of a Freon refrigerant through a heat exchanger is 10 kilograms per minute. The enthalpy of entry Freon is 245 kilojoule per kilogram. And the enthalpy of exit is 55 kilojoules per kilogram. Per kilogram ta. Water coolant is allowed to use 10 degrees Celsius. Determine the water flow rate. Now, this is simple heat exchange, okay? For the heat exchange, the Q is always constant. Okay? Kung ano daw yung heat that is given off by your freon, that will be the heat that will be received by your coolant, water. Okay. In any flow, okay, Q, diba? Q is equal to delta H. Tama? So, that is M delta H equal to M Cp of the water delta T. As always, tignan nyo to As always, in order for you to get yung mass of the cooling water is always equal to the mass nung iyong fluid, okay? You multiply it with the hot enthalpy, okay? High enthalpy minus enthalpy at high minus enthalpy at low divided by Cp of the cooling water, then delta T, T hot minus T low. Now, okay, the Cp of water, to recall, that is what? 4.187 kilojoule per kilogram, the same with Cv. How about kapag ice? The Cp of ice is always half of water. Cp of ice is equal to the Cp of water half. Now, kapag ang Cp ng water is 1 BTU per pound degree Rankine, ang ice is always 50% of that Cp. Okay? This is the formula, kahit di ka na mag-algebra. Now, I do recall that there is another way for you to solve the heat that is received by water. Okay? The heat that is received by water, only thing, okay, Q is equal to 8.33 V, okay, the volume flow rate of water, delta T. Okay. Ang lalabas po dito is in BTU per minute. Ano po ang unit nito? This is in GPM. Ano pong unit nito? Degree Fahrenheit. Now, sir, shortcut na ito. Oo, kapag naka-English units ka lang. Units only. Okay? Ma-encounter natin yan pag pumunta tayo ng refrigeration and air conditioning. Pero ito, another formula to take note of. Okay? This is I think this is part of your air conditioning and refrigeration, pero mas gusto ko ituro ko na sa inyo. Okay? Kapag naka-GPM, delta T, you don't have to multiply it with 62.4, yung specific weight of water, as is na. Kapag naka-GPM, delta T, basta water Now, going back. This is the shortened formula for the cooling water. Given yung mga enthalpies, the temperature change, the Cp of water that is constant, and then given the mass flow rate. Now, we can solve for the mass flow rate of water. So, the mass of the cooling water in kilograms per minute, given naman dyan in kilograms per minute yung sa Freon, that is 10 kilograms in every minute. The entry and exit will be 245 hot, 55 low, 245 minus 55 kilojoules per kilogram. And then the Cp of water, 4.187 kilojoule per kilogram, degree Kelvin. And then the temperature change is 10 Celsius degree. O, the change in temperature, canceled na yung Kelvin dyan. So, we cancel the same units. Kilojoule, kilojoule, kilogram, kilogram, degree Kelvin, and Celsius degree, the same. So, the mass of the cooling water now will be, okay, solve natin. That is 10, 245 minus 55, 4.187 times 10. That is 45.38. 45.38. Tama ba? 45 yun. Yeah. So, 45.38 kilograms in every minute of cooling water. So, that is for problem number 13. So, let me take a 5-minute break.